This video is going to cover positive predictive value and negative predictive value, mostly in the context of sensitivity and specificity, just kind of differentiating the subtle difference between the two. So in another video I talked about sensitivity and specificity, and they're all about figuring out how good our test is at identifying those who are truly disease positive and truly disease negative. Well, positive predictive value and negative predictive value are all about how much should the results of our test be trusted. And those sound pretty similar, but I'm going to go over an example that kind of differentiates the information that the two types of values are giving us. So just to review, sensitivity is the number that are test positive and disease positive over all that are disease positive. So the proportion of all those disease positive that we were able to capture correctly. And specificity is kind of the converse, in the sense that it's the proportion that are test negative and truly disease negative, so true negatives over all that are truly disease negative. So the proportion of those who are truly disease negative that we got correct. Positive predictive value is the probability that you are disease positive given the test said so. So it's the number that are true positives over all that the test said were positive. And yeah, A over A plus B. And negative predictive value is the probability that you are disease negative given the test said you were disease negative. So you can kind of see that positive and negative predictive value are more about evaluating how useful or trustworthy the test is. Well, the context of sensitivity and specificity is more of those who you of those who are truly disease positive, how many do we get? So the main thing that changed here is the denominator. So the denominator for sensitivity and specificity are those who are is truth, basically. It's what we got correct out of the truth. And positive predictive value and negative predictive value have the denominator as everything the test said. So how often was the test right out of everything it said? And yeah, that wasn't a great explanation, but yeah, I'm gonna do an example, and that should help. So here's our example with real data, or well, real numbers in the cells. So sensitivity is all about this disease positive cell. Like I said, it's the number the test got right as far as positives, number of true positives, over all of the positives that were there to get. So 55 over 55 plus 4. So it got 93% of the truly diseased population. Specificity is D over B plus D. So the number that we got right that are disease negative, that we tested as disease negative, over the population that is truly disease negative. And that comes out to 70%, so not great specificity. Positive predictive value here has the same numerator as sensitivity, the number that are test positive and disease positive, so the number that we correctly identified as disease positive, over everyone we called disease positive. So A over A plus B, and that comes out to 68%. So 68% of those who we called test positive really were. And negative predictive value, D over C plus D, the number that are truly disease negative, true negatives, over everyone we call disease negative. So 62 over 4 plus 62, and that's pretty good negative predictive value. So putting all this together, what do we know about our test looking at all of these values? Well, we have a sensitivity of 93%. So the test correctly identified 93% of those that are disease positive. So the the test is good at finding the disease when it's there. It has a specificity of 70%. So the test correctly identified 70% of those that are disease negative. So the test is pretty bad at correctly identifying disease negative people. And now looking at the predictive values, so the positive predictive value was 68%. So of those, the test called disease positive, only 68% really were. So if you took this test and the test said you have the disease, you should get a second opinion. There's a good chance you might not have it. But as far as a negative predictive value, it's 0.94, so 94% of those who we called disease negative really were. So when the test says you're disease negative, you can be pretty confident that you are disease negative. So yeah, I hope this helped illustrate the subtle differences between sensitivity and specificity and positive predictive value and negative predictive value. I have another video on false positive fraction and false negative fraction, which are kind of related concepts.